1A, you have question 21 and 23. So, what will the observation, okay, when we add the coral iron, okay, into solution with silver iron? Of course, we will have a white precipitate form. Is the observable change. The second one, okay, what iron you are testing is about chloride iron. Chloride iron, okay. And then the setup, okay, is distillation. Distillation, the name. And the setup, okay, is something I put it in the notes. Okay, you have a thermometer and then pH flask, and then you just simply remove this word, and then we heat it up from the pH flask, and then we collect distilled water, and this is a setup for distillation. And not so difficult. I think you have practiced several times. And of course, because your answers are exactly the same from each other, so I will go to another section. So what will be the observation, okay, for calcium carbonate placed in acid, okay, the word effervescence, okay. And I want to have a more picture about this observation. And as the lab reports are in my office, okay, I will let you know later. But I want to remind you for this observation, only for carbonate react with acid or hydrogen carbonate react with acid. But I found many of you, for last lab section, we place magnesium into citric acid or hydrochloric acid, and of course you can form bubbles, right? But we seldom, or we should not use effervescence to describe this observation, okay? But I find that many of you, over half the class, use effervescence to represent the observation between magnesium and acid. But in fact, we should not use this word. So, what should we use? We should simply use colorless gas bubbles evolve. Okay? Once again, for this question, of course, you write down effervescence. However, for the results of yesterday's practical, we place magnesium into hydrochloric acid, and there will be colorless gas bubbles evolved, but not effervescence. You get my point? And what is the material inside, of course, calcium carbonate? So for part C, it's about the procedure of frame test. I find that many of you exactly the same answer but miss one point. The point is that we need to observe under non-luminous frame and test under non-luminous frame. What means by non-luminous? That means nearly no color of the frame, so that when you place a sample in a Bunsen frame or in the non-luminous frame, you can observe the correct color. However, many of you write down Bunsen frame. Okay, it's not very accurate, because I know, but I mentioned, I write it down for the procedure in frame test when in my lesson. I strongly emphasize this word because for Bunsen frame, you may find blue, or if you close the air hole of the Bunsen burner, the frame color will be yellow or orange. So it will affect the results of the frame test. So please write down non-luminous frame. Okay, is a much better word. And of course, maybe for some markings, okay, you find the Bunsen frame is in marking. However, I will teach you the correct one. Okay, you should use the non-luminous frame. Okay, and then this question, okay, one of your students asked me through WhatsApp, okay, and I want to elaborate more. So how can you arrive the results accurately? Okay, maybe you can repeat the experiments for several times, or use distilled water, or use clean equipment, or no contaminants in the reagents. Okay, all of this can ensure the result of the experiment are to be correct or to be accurate. Okay, so you try to have this idea, because for public exam there may be some similar kind of question. Okay, so let's go to another question. Okay, for 1B. So what is the atomic number means? Of course, means a number of proton of the element. And for that second part, okay, why RD in group 7? Okay, you need to mention number of outermost shell electron is 7. I don't know why some of you write down that because outermost shell electrons is 8, or it is group 0. Of course, it is totally wrong, because no matter iodine, bromine, chlorine, fluorine, all are group 7 elements, not group 0. And why I place gallium, okay, in this in the same group? Because the oxide reacts with the acid, okay, have the same observation. Remember why we place the elements in the same group? Because they have similar chemical properties, right? So we're trying to find out from the question. The question give you about melting point, about chemical properties. So we try to use chemical properties instead of physical properties. Okay, it is the best answer. For example, why we place sodium, potassium in the same group, group 1? Because when they place in water or when they place in acid, they have the same observation. But of course, different rates of reaction. So we try to use chemical properties rather than physical. So how about the chemical formula of gallium oxide? If it is in group 3, so exactly as aluminum oxide. So what will the formula mass for the oxide formed by aluminium? Okay, for this one, 27 is aluminium. And for 16 is O, as the formula for aluminium oxide is Al2O3. So with 2 times 27 plus 3 times 16 and equals 102. No units for formula units. Okay. And for 3, so how can we say about this compound? Okay, maybe they have a high melting point, boiling point, and usually for our compound, okay, we should write down this one. Okay, conducts electricity when molten. Remember, they are electrolytes. Okay, when molten. So why we have in group 0? One word is much better. Okay, we should use fully filled outermost shell. Okay, always correct, always true. But I find that some of you write down because outermost shell electrons is 8. But I'm so sorry, there is one exceptional case. Okay, as helium, it is in group 0. However, the outermost shell electron is only 2. So if you write down all group 0 elements, okay, with outermost shell electrons equals 8, it's not totally correct. If the marking at that year is very tight, it must not be the correct answer. So how? Maybe you can use, okay, for neon, okay, 8 electrons, for helium is 2, so they are stable and placed in group 0. Or we simply remember one sentence, is this one, okay? All group 0 elements with fully filled outermost shell electrons, that's all. So you better use the red one, okay? That means here, we better use these words to explain why group 0 elements with a stable electronic arrangement or with high stability. So, next question. What is the definition for relative atomic mass? Okay, you simply copy from your textbook. And I think 2 words you need to mention. The one is weighted average value of isotopic mass. The second part, many of you missing it. Okay, compare with carbon-12 scale, or you write down compare with 1/12 of mass of a carbon-12 atom. And then, of course, for calculating isotopes, 2 kinds of calculations. The first one is try to find out the relative atomic mass. The second one is find out the relative abundance of one of the isotope. So for this type of question, we try to find out the relative abundance. So we have the silver relative atomic mass 107.9. And then one of the isotope will be 107.1 with 54%, but I use decimal numbers. And then we let the other relative isotopic mass is Y, and with 46%, that means 0.46. And eventually we can calculate Y. You can choose either 4 significant figure or 3 decimal places. And for this answer, I choose 4 significant figure. Okay?